Welcome to another Warmaster's Workshop tutorial. In this tutorial, we're going to learn how to build a remote control rangefinder stock. Rangefinder being the antenna-looking thing on the right-hand side of Boba Fett's and Jango Fett's helmet. We're going to make it so that when you press this little key fob, your rangefinder is going to go down, and when you press it again, it's going to go up. This is not as complicated as that may seem. Really, it's more of an exercise in patience than anything else. So let's talk about the parts that we're going to need here. First and foremost, we're going to need this little device here. This is called an Arduino Nano. It is a very small microcontroller. It's a very powerful microcontroller. These are extremely cheap. You can get, on Amazon, you can get a pack of 3 of those for like $8. Next is going to be this is our radio-controlled relay. Again, it's a very small device. It doesn't have a whole lot of wires there on the back. It's got a positive and a negative. That yellow wire is the communications wire. The blue wire we're going to be bridging over to the ground on for this particular project. This will actually handle up to 12 volts as far as being powered. Well, you can power it up to 12 volts and as low as 3.3 volts, which is exactly where we're going to be powering it from the Arduino itself. So we don't need any external power for this specific project. You can for the servo, but you won't need it for the RC relay there. This is the key fob that actuates the relay. My advice would be to, when you use this, incorporate this into something. You can put it in your gauntlet, you can put it in your blaster, you can put it in whatever, but make it so that you can push the button, and there's another small antenna coiled up just like on this. You'll want to put that somewhere where it can transmit out. And then last but not least is our servo. And this is actually a relatively large servo, so this has quite a bit of torque to it. My advice would be maybe get more of a slimline servo. This will work if you have a small head. If you don't have a small head, it's not going to be very comfortable. But they do make the slimline servos that are actually a bit longer and slimmer. They also make micro servos. You can always test one of those out. They're not super expensive. I want to say this servo might have been $11. This whole setup itself was maybe right about $30 after tax for all the pieces here. So it's not an extraordinarily expensive project to do. It's really just it's more of a it's electronics, and people get very intimidated about that. So this tutorial is to help you not feel intimidated when going into this. So anyway, let's go ahead and let's get started putting this together. 5, 4, 3, 2, 1, action. All right, so before we start soldering on our Arduino, we're going to go ahead and start here with bridging where it says no. We're going to bridge the no. The bottom, the blue wire, we're going to bridge that to the ground wire there at the top to the black wire. So what I'm going to do, I'm just going to pull this over and measure and see exactly how much we're going to need to bridge that. I'm going to take my wire nippers here. I'm going to nip that wire down. And then I'm just going to gently, very, very gently, pull the plastic. I'm probably going to hit the camera. Sorry about that. There we go. I'm just going to pull the plastic away ever so gently. Doesn't look like it's enough. I don't want to break this wire. go. Now we're just going to twist this up, just like so. Just want to get enough solder on there to basically pin that, the end of that wire, to our ground. Let's wind this up a little more. I like making sure these ends are twisted nice and tight because we're going to nip it really close, right about there. And that should give us the clearance that we need. Alright, so let's go ahead. Let's get our soldering gun and our solder. I'm going to get the camera close here. That's all you need, just that little bit. There you go. See, just that little bit of solder. Let's nip that. So I'm going to take these and just flatten that out just a touch. There we go. Then I'm going to take my nippers, and there we go. So we've got our wire, our blue bridge to ground, and now we're ready to wire this up to our Arduino. Alright, so in order to get our rangefinder to work, we have to use or upload some code to our Arduino Nano microcontroller in order to get it to actuate the server when we press the key fob. So to do that, I've actually found it's actually the perfect code to do it. It's basically a push button code that actuates a server to move 90 degrees and then back to 0 degree on the server. And I'll put the link to where you can find and download this code on the internet. You can, but just a quick reference, you can find it here at ArduinoGetStarted.com. And the name of it is Arduino Button Servo Motor. So this whole tutorial actually teaches you how the code makes the servo work. And we're just going to do a very brief overview of what this shows. And here is the wiring diagram, and this is basically the same wiring diagram that we use for the remote control, the little relay. So the relay, the yellow cable for the relay, or what's called the communications cable, it goes to pin 7 or D7 on the Arduino, and then the other side of the communication, or the other side of the relay, goes to ground, and then it also goes to the 3.3 volt. The red wire on the relay also goes to the 3.3 volt connection coming out of the Arduino Nano. And then the servo connects in the same way as it does here on the Uno. It goes to pin, the communications cable goes to pin 9 on the digital header. And then you've got the 5 volts going to the servo and the ground going to the servo. So let's talk about this code just very briefly. The code itself is actually pretty simple. If we go down here and we look at the first part of the code, talks about the pin, which port on the digital header is for the pin, which is going to be number 7. That's the button pin. And then you've got the servo pin that's coming in on digital number 9. Down here you've got what the actual variables will do when, so the variable being when you push the key fob and it actuates the relay. When it is actuated, it's going to go to 0, and then the last state of the button, it's going to read what happened the last time the button was pushed. And then it's also going to take into consideration what the current state of the button is, which is what it is now. So if you push the button before, the Arduino code is going to say, okay, well, he pushed the button, or they pushed the button before, they're pushing the button again, so that means the servo is going to move. And then, of course, right here is we're initializing the serial transmission, which is at 9600. That's the speed, or back in the day, we'd call that the baud rate. And then right here, we're actually setting the pin mode to pull up. And that pull up is actuating a resistor inside of the Arduino. It's called the pull up resistor. I can't remember what exactly the resistance is on that resistor, but you can look it up. I mean, it's not super important. And then, of course, right here it says servo attach. That means it actuates the servo on the pin 9, or it attaches the servo on pin 9. And then down here at the last segment of the code, or the third segment, it says the last button state equals the current button state. So it's basically saving the last state, it's reading the new state, and then it outputs that to the servo. So right here it says last button state equals high, current button state equals low. It says let's change the angle of the servo motor. If the angle is 0, so if the motor is sitting straight up, it's going to move it to 90 degrees, which is, on the rangefinder side, is going to be down. And then if the angle is down, it's going to move it up. And then it's going to, at that point, it's going to stop the program until it's initiated again. So it's very simple. This tutorial is great to actually kind of guide you through exactly what is going on. And if you're planning on using Arduinos more in your armor or in your projects, which I suggest because they're great little tools, they're super inexpensive, and they can actually do a lot. I mean, this is just a very simple, this is a super simple program, and you can actually write these things to be, over 100 lines long easily. The only thing that limits you is the amount of memory that's on the Arduino that will hold the program. So I would say get an Arduino Uno first, which is the larger, the full-size Arduino. Get one of those, use that for prototyping. You can move everything you do to that over to a Nano. For the most part, of course there's less pins on a Nano, but you can move just about everything from a Uno to a Nano. That's what I do. I prototype on my Arduino Uno, and then I move it over to my Arduino Nano, or even Arduino Pro, which is even smaller. Believe it or not, they do get smaller. So anyway, here's where you get your code, ArduinoGetStarted.com. There's tons of different projects in here that you can play with. We're going to go ahead and upload the code. So I've already got it here in my in the Arduino IDE. I have it copied in here, and all you have to do at this point, I like to do a verify and then an upload if it's the first time I'm using it. Otherwise, you can just do an upload, and it will compile it, and it will shoot it right over to your Arduino at that point. Once your transmission light is done on your Arduino, once it finishes blinking, then you can start using it. It's that simple. All right, so we're going to plug our Arduino into our USB, and this takes a mini USB, not a micro USB, but a mini USB, like what some of the older digital cameras used. But once we have it plugged up, you'll see lights come on. You should hear your computer make the little USB hardware recognition sound. So what we're going to do now is we're going to go up here to the upload button, and we're going to hit that. And you're going to see a green line move at the bottom of your screen, and you're going to see the lights blink on the Arduino. Once the light stops blinking, you know you have uploaded the code, and then from there we can begin actually attaching our components to the Arduino, and we're going to do that one pin at a time so you can see exactly what goes in what pin. All right, so we've got our Arduino and our RC relay here. Let's go ahead and we're going to hook that up to our Arduino. So we need to do ground. We're going to do our ground on the digital header, which is right here. I'm going to point each of these out before we even hook anything up to them. So we're going to use, for the RC relay, we're going to use this ground on the digital header next to D2. So right here where it says GND, that's ground. We're also going to use the 3.3 volts, which is right here. And then we're going to use D7 as our button pin for the yellow line. So let's go ahead and attach to ground first. And then now we do our 3.3, which is up here. And then our pin 7. Which is right here. So let's go ahead and get these soldered. The trick to soldering well is to heat the wire. Let the wire do the work. And one thing I want to do here before I solder is just make sure that this ground line is in here nicely. I don't want to, I'm not a big fan of saggy lines. Turn this, there we go. Perfect. All right, so let's clip our lines. One, two, 3. All right, that's looking nice. Very nice. All right, so we have our power, ground, and communication line hooked up. So now, I did this before we started taping, but I created a really nice plug, another a little mini Molex here for our servo. I'm going to put it in my hand here so it'll focus. There we go. So all we have to do now is connect these lines to our, this goes to pin 9. This is the communication line to the servo. Raise this up just a little bit. There we go. This is our communication line. This is our ground line right here. And this is our 5.5 volt power line. Now we're going to put this into pin 9, the communication line. And then we're going to put this into the ground line into this ground. Hold on, let me. Go. So we're going to use the yellow cable goes here. Oop. Yellow cable is going to go right here into D9, digital 9. Ground cable is going to go here into ground. And then our power cable is going to be right here, 5 volts. We have our remote control relay on ground here, and we also have it on 3.3 volts here, and we have it on communication pin D7. We have our servo communication pin on D9, and we have the servos powered by 5 volts, and the servo ground right there. So now all we have to do is we plug in our Arduino. Oop. So let's get that plugged in. And I don't think you could hear it, but I got the happy USB chime of connectivity. Now we're going to plug our servo, which here's our servo. Let's go ahead and we're going to plug that in right here. And now we're going to pull the camera back a bit. Now we're going to hit our keychain. Oh. That's what we want. I don't know if you can hear it. So let's go ahead and we'll set this up so that we can watch the we can actually watch it, the servo go up and down. So we've got our rangefinder stock set up. I'm going to pan up just so you see it here, all the way down to here. So that's a 3D printed rangefinder stock. I also have the cap, but I can't attach the cap to this because the stock and cap is what I use to make molds off of. But I will show you that it can lift the full rangefinder, including the cap. It'll throw the cap if I have it on right now. But let's go ahead and actuate the Arduino, and you'll see the rangefinder go down, and then it comes back up, just like that. Now you got to give it you've got to give it a couple seconds to run through the entire program. If you don't, and you just sit there and you press it, it's not going to do anything until it's ready to do it again. So there is a small delay there, but nothing that's really noticeable. So let me pull the camera back just a little bit more, and you can see the full rangefinder going up and down. So here I'm going to put the topper on. I'm actually going to hold the servo because if I don't, it's going to make the whole base move. See, it's a lot of torque. Now, the topper is on it right here, as you can see. Now let's go ahead and bring the rangefinder back up. So it will carry the entire rangefinder. So the weight is definitely not a problem. One thing to remember too is this is not a high torque servo. This is just the standard servo. Okay. Also, I want to show you a neat little thing that you can watch when you're putting this together. So when you're actuating the RC or the relay here, the module, see that? this is the TX light. Let me see if I can zoom down on that. You'll see that TX light, that's the transmit light. Every time that servo actuates, you know it's working if you see that little light blink. So you could actually write your sketch to output the transmission LED to a different one of these pins. Not that that's really needed, but you could do it. Another thing you could do too is if you had a hollow rangefinder stock, you could run a battery, or not a battery, but a line up through that stock. You know, some really tiny wires, and have them actuate a blink when the rangefinder was down, and then on last button state, I'm sorry, on current button state, when it comes back up, the LED lights would turn off. So, you know, you'd have it, if you wanted to do a Canon boba helmet where you had the lights in the LED, or the LEDs in the inside the rangefinder, where it shows them blinking there at the top of the rangefinder, or not, you can create your own little sequence, whatever, but that's totally possible in this same sketch. You just have to write it in there. So there's a lot of possibilities here with this Arduino Nano. But for the sake of this tutorial, all we're really worried about is getting this to go up and down, which we have successfully accomplished. So thank you for joining me for this Warmaster's Workshop tutorial. I look forward to seeing you build your own remote control rangefinder. This can also be used for other things like remote control macro binoculars, if you have one of those that come down over your T-visor on your helmet. My only suggestion there would be that you would absolutely have to power your servo externally. So you would need a 9-volt power supply, like a 9-volt battery at minimum, for something of that nature, because you're talking about a high torque servo required, which is going to pull quite a bit of current, and because there's a lot of gravity involved in moving these devices up and down. Anyway, thanks for joining me for this month's Warmaster's Workshop, and we will see you next month in Warmaster's Workshop.